We're going to take another stab at question 2 from assignment 3.8. In the first video, I did that problem using 1/2 powers instead of leaving radical symbols. So let's see if we like this problem a little better if we do the algebra simplifications using square roots. So there was no problem with the first one. When we found the first derivative, you definitely are thinking the power rule, so no problem there. So we have 1/2 x to the negative 1/2 plus 1/2 y to the negative 1/2 with a chain rule always on the y. So we multiplied everything by 2, no question there. And then when I want to rewrite this, if I go back to our other symbols, so this is move this term to the other side, and it would be negative x to the negative 1/2. So I might put it in this format. And on this side, this y to the negative 1/2 is 1 over the square root of y. So here's our alternate form. So we've seen this before. So let's leave our first derivative in this form. And now let's do our second derivative, the derivative of the derivative. And to do our derivatives, you probably are going to think in terms of the quotient rule. Let's this time, so it's different from the last, let's bring that negative sign out in front of the derivative, put it back in later. The only thing you have to be careful, make sure that you don't forget to put it back in later. And let's write this as y to the 1/2 over x to the 1/2 at this point, just till we get to our next step. So our second derivative will be equal to that opposite sign in front of our quotient rule. So our low function, our derivative of the high function, 1/2 y to the negative 1/2 with a dy dx, or a y prime if you prefer, minus our high function times the derivative of the low function, 1/2 x to the negative 1/2, all over the low function squared. All right, so now let's go back to our square root notation and see if we find the algebra a little simpler. So our square root of x stays in the numerator, and we'll have a 2 square root of y in the denominator. And then immediately I'm going to do my substitution here for y squared. We know what y squared is from our first step. So I'm putting in y prime. And then I'm going back to the second part of our numerator. We've got the square root of y in the numerator. And 2 square root of x in the denominator. So nothing wrong in the first video if you've watched it. Here we're just, instead of 1/2 powers, we're looking to see if you like the algebra a little better when it's written in this form. So this needs a square root symbol right here. So I think it's just a little bit more visible to everyone that these square roots of x cancel and these square roots of y cancel. So now when I clean this up, this first term has a negative here, but it has this negative on the outside. So if we now distribute that negative, we'll be back to a positive, and we just have a 1/2 left from that first term. And our second term will be positive, and we've got square root of y over 2 square root of x all over x. So to remove the complexity, so you can see that this is not really different than the previous example. I'm just using different notation. So multiply through by the common denominator, and of course remember we're distributing here in the numerator, so the 1/2 cancels. So we've got the square root of x and the square root of y, and our denominator is 2, and then x square root of x. And this is where our second substitution comes into play. We know the square root of x plus the square root of y. From our original problem, square root of x plus square root of y is exactly equal to 1. So this is our substitution step here. And how could we rewrite this denominator? You can see this is x to the first times x to the 1/2. So you could add exponents to write it that way, or you could leave it as the square root of x to the third. All three of these versions, all three of these denominators would be equivalent choices.